Imagine a child looking around an empty room, realizing their white, furry cat is missing. They have a problem. They need to find an object, but they have zero data on its current location. If the goal is simply to find the cat, every room and every corner represents a potential hideout. Without specific location words to divide the space, the search lacks a logical starting point. To solve this, we begin looking for my furry cat by actively assigning spatial coordinates to the different zones inside the house. We check the elevated spaces, like the window shed, then move to ground-level zones, checking the area underneath the bed. Pairing physical objects with relational words, like on the shed or under the bed, creates a searchable map used to systematically rule out hiding spots. Moving into the living room, we apply the first set of opposing coordinates, the boundary of a container, defined as inside versus outside. If the cat crosses the threshold into the enclosed space of a backpack, it occupies the inside coordinate. If it remains in the open space surrounding the red storage rack, it is in the outside zone. Next, we measure vertical space relative to everyday household objects, creating a second binary, above and below. In this panel, the cat's physical position underneath a floor covering verifies the concept of below. The first panel shows the opposite, the cat's elevated trajectory over a brown hat, demonstrating the concept of above. These paired opposites, inside and outside, above and below, function as a localized grid. They narrow down the search area and turn a cluttered room into an organized, trackable environment. The search perimeter extends into the yard, where the vertical scale expands to include the absolute limits of an object, top and bottom. In the top half of this image, the cat scratches at the bottom of a glass jar. In the bottom panel, we track its maximum elevation as it sits on the top of the red car. Establishing these extreme upper and lower boundaries completes the positional mapping of the immediate property. Every square inch is now accounted for. With the entire area mapped and measured, the search yields a result. The child finally locates and embraces the white cat. Identifying the correct positional data eliminated the confusion, leading directly to a successful resolution. Now that we have mapped a single house, we can test this framework against the broader physical world. Consider the position of this white cow in the yard. It is clearly separated from the farmhouse, occupying the outside zone. Just behind it, look at the cat leaping out from the window shed, actively crossing from the inside of the building to the outside. We see this boundary in motion as a ball crosses a basket's rim. At that threshold, we define the trajectory as in or out. Linear coordinates like before and after expand the framework further, organizing objects that move in a sequence. Heavy transport vehicles demonstrate this clearly. One car must physically follow another, with one bogie appearing before or after its neighbor to maintain the sequence of moving units. Whether tracking a pet through a living room or organizing transit units on a track, these positional words provide the structure needed to navigate our surroundings. They turn a physical environment into a clear, communicable map.